Now we are starting our chapter 5th, that is surface chemistry. And surface chemistry is the branch of chemistry which deals with the nature of the surface and the species present on it. This surface chemistry will involve the topics like adsorption, and adsorption is what the phenomenon of higher concentration of the molecular species present on the surface of the solid than in the bulk is known as adsorption. We know that the solid molecule on its surface have some residual forces due to which the molecules of the solid or liquid attracts on it. As a result, the concentration of the solid or liquid on the surface becomes more than in the bulk, means in the center of the solid the number of molecule particles are lesser than on the surface. Therefore, this phenomenon is known as adsorption. So, the surface of the finely divided solid may have residual forces. Residual mean unequal forces. Due to these forces, the surface of the solid has a tendency to attract the molecules of the gases or a liquid when they comes in contact with it, and they form a bond with it, and that's why they remain on the surface of the solid and do not enters into the bulk of the solid. And this phenomena of more concentration on the surface of the solid than in the bulk of the solid is known as adsorption. Now, adsorption consists of two components. One is your adsorbent and the other one is your adsorbate. The substance, the solid substance, we can say, on whose surface the adsorption occurs is known as adsorbent, and the molecular species that get adsorbed on the solid surface due to the intermolecular forces is known as adsorption. I have done here an example. Suppose this is a solid surface, and due to the residual forces, due to the valence forces on the surface, these are the molecules which has made some intermolecular attraction with this solid surface. So this solid surface is known as adsorbent, and the molecules which get adsorbed on the surface of the solid is known as adsorbate. So together this adsorbate and adsorbent give rise to a process known as adsorption. I have given here the formula examples. For example, organic dyes get adsorbed on the surface of the adsorbent, that is animal charcoal. And another example is raw sugar, which is brownish in color. When it is placed in a pinch of animal charcoal for some days, it becomes decolorized. So here the raw sugar will be your adsorbate, and the animal charcoal, that is the surface provided, the solid surface provided for the raw sugar molecules to get adsorbed, is known as your adsorbent. Now here, how the mechanism of the adsorption take place. It is a surface phenomena. I have given you the molecules present, atoms present here on the surface, and these atoms are having weak van der Waals forces between them, and this is the covalent bonds present, okay, in the form of weak van der Waals forces, and these are the residual atoms on the surface of the solid which act as an unbalanced force present on the surface, due to which attachment of the molecule take place. Now if we break these molecules into different parts, let's see, I have broken this bond first and then this bond, we have get many unbalanced forces. This means smaller the solid substance is, finely divided solids have more unbalanced forces, therefore they are having more attractive centers. Free valencies become more by taking adsorbent in the finely powdered form, due to which more attraction of the molecule can take place. This means that finely divided solid can becomes a good adsorbent than that of a complete solid molecule. For example, if we say a finely divided charcoal is better adsorbent than that of a solid charcoal. Adsorption can be of two types here, positive and negative adsorption. If the concentration of the adsorbate is more on the surface than on the bulk, this is the bulk. Bulk mean in the center of the solid. So if the concentration of the adsorbate is more on the surface than in the bulk, it is known as positive adsorption. And if the concentration of the liquid or the gaseous molecule is more in the bulk than on the solid, it is known as negative adsorption. I have given you an example here, that is, if when concentrated KCl solution is shaken with bone charcoal, then it is an example of positive. In this case, the KCl molecules will be more on the surface, where if dilute KCl solution is taken with the bone charcoal, then the concentration of KCl will be more in the bulk than on the surface. Therefore, it is an example of negative adsorption. If we can say that if adsorption is not taking place, it means if concentration of the molecules are not more on the surface, then it is negative adsorption, and if the concentration of the molecule is more on the surface, then it is a positive adsorption. Now there is another term known as desorption. Desorption is a reverse of your adsorption, because we know that adsorption is a reversible process. Means whenever adsorption take place, there is a bond formed between the adsorbent and adsorbate, and in desorption process, the adsorbent and adsorbate is broken. The bond between them is broken up, and again they are liberated out. So adsorption is again broken down into adsorbate and their adsorbent. Suppose I have given here the adsorption process is there. More concentration of the molecule has taken place on the surface of the adsorbent, and during the process of desorption, these molecules are liberated out as adsorbate and adsorbent separately. This process is known as desorption. Then there is another term known as absorption, which we know it is a bulk phenomena, whereas the one adsorption is our surface phenomena. So it is a bulk phenomena. Absorption mean the molecular surface when the molecular substances is uniformly distributed throughout the body of the substance. Means if the liquid or the gases are uniformly distributed, the concentration is more in the bulk than on the surface, is known as absorption. See here, this is the concentration is more on the bulk than on the surface. This is your absorption, whereas here the concentration of the molecular species is more on the surface than in the bulk. This process is your adsorption. So here this one is your bulk phenomena, whereas this adsorption adsorption is your surface phenomena. Then there is another term comes, that is known as sorption. Sorption means when adsorption and absorption take place together, mean the concentration of the liquid or the gaseous molecule is uniformly distributed throughout the surface as well as in the bulk. When both the processes are taking place, it is known as your sorption. Thermodynamical feasibility of adsorption. This means the change in enthalpy taking place for the adsorption of 1 mole of the adsorbate on the surface of the adsorbent. This means that when 1 mole of adsorbate is added on the surface of the adsorbent, some enthalpy is changed, some heat is released out during this process, and this change in enthalpy is known as thermodynamic feasibility of the adsorption. And we know that any reaction is feasible when delta G, Gibbs energy, is your negative, and for this the equation is delta G equal to delta H minus T delta S, where delta H is our enthalpy factor, T is our temperature, and delta S is our entropy factor. So whenever a molecule of liquid or a gas is attached with the solid surface, its randomness become less, therefore the entropy factor will be less, becomes negative, and this T delta S will become negative only when the temperature will be low. As I have told you, during this process of adsorption, heat is released out, therefore the enthalpy factor, that is delta H, is always favorable and it is always negative in this process. So the feasibility of the reaction only depends upon the temperature. If the temperature is low, the adsorption process will be feasible, but it will become non-feasible when the temperature is high, and the process of desorption take place at that time. Desorption, as I have told you, that it is the separating up of the adsorbate and adsorbent from the surface of adsorbent, and on the basis of the forces of attraction between the adsorbate and adsorbent, we are having two types of adsorption processes. First one is our physical adsorption, that is physisorption, and during this process, when the physisorption is taking place, the force of attraction between the adsorbate and adsorbent is very weak van der Waals forces, and whenever the molecules are joining with each other with the solid surface, the very low amount of heat is released out. Therefore, the heat of adsorption is very low, and this takes place at a very low temperature. It is not specific in nature. This means all type of gaseous molecule can be adsorbed on the surface of the solid, and it is multi-molecular layer under pressure, because once under the pressure, these molecules which we call it as adsorbate molecules get adsorbed on the surface of the adsorbent. They can form the multi-molecular layer, and they do not have any activation energy required. The activation energy is the energy required for any reactant to change into product. The next category under this one is chemisorption, or we call it as chemical adsorption. So the force of attraction between the adsorbate and adsorbent in this chemisorption is a strong chemical bonds. As a result, a high energy is released during this process. Therefore, heat of adsorption is very high. It occurs at a very high temperature, therefore, and it is highly specific in nature, because only those which can form bond between the adsorbent and will be allowed to undergo the adsorption process. Those who are not able to form the bonds, if the bond is not present between the adsorbate and adsorbent, no adsorption process take place. Therefore, it is highly specific in nature, and it's from monomolecular layer, because once the bond has been formed between the adsorbate and adsorbent, no other molecule can form bonds with the adsorbent. Therefore, even under high pressure, we can't form the multimolecular layer here. Therefore, chemisorption always forms a monomolecular layer. Now our next topic for adsorption is adsorption isotherms. We know that pressure and temperature are the two main factors which can influence the extent of adsorption on the surface of solid. If temperature is kept constant, then it is known as isotherms, and if pressure is kept constant, then it is known as isobars. ठीक है, iso means same and therms mean temperature, and if we plot a graph between the extent of adsorption and the pressure, xm here represent extent of adsorption, where x is the mass of adsorbate and m is the mass of adsorbent at equilibrium, and P is the pressure here. If we plot a graph between x by m and pressure at a constant temperature, this graph is known as adsorption isotherm. We know that when adsorption take place, some heat is evolved out, and adsorption is a reversible process. The adsorbate and adsorbent are enclosed in a closed container. Suppose a stage will be reached when the amount of gas adsorbed becomes equal to the amount of gas desorbed, because at higher temperature desorption process starts taking place. This state is called equilibrium state. Means as we move increases the temperature, so reverse process will take place. But here, as the temperature has to kept constant, we are changing the pressure, and in changing the pressure, in the low pressure, the extent of adsorption of the gas or a liquid on the solid surface increases, and it reaches to a point from where the increase of pressure does not have any effect on the adsorption of gases, and that is the state of equilibrium, which is known as pressure equilibrium state. Okay, this is the plot for isotherms. If we move for the isotherms again, at equilibrium pressure Ps, Xm reaches to its maximum value. This state is called saturated state in adsorption. Isotherms are only for the monomolecular layer of adsorbate on adsorbent. I have told you how the monomolecular layer is formed on the solid surfaces. So this graph has been obtained, which is your isotherms. Again repeating, we have kept the temperature constant here because on increasing the temperature, the desorption process will take place. So keeping the temperature constant, if we are increasing the pressure, the rate of adsorption first increases and then it reaches to an equilibrium state. There are two types of isotherms. One is your Freundlich adsorption and the other one is your Langmuir adsorption. In detail, we are going in 12th class Freundlich adsorption. In this adsorption, I have made this graph between X by M and pressure. You can see here as the temperature is decreasing from 273 Kelvin to 240 Kelvin, then 200 Kelvin. As the temperature decreases, the rate of adsorption increases. First at this pressure, the rate of adsorption is this much. At the same pressure, the rate of adsorption is this, and at the same pressure, the rate of adsorption is this for different temperature. And we have seen that as the temperature decreases, the rate of adsorption increases here. So at the lower temperature, X by M is directly proportional to P, that is pressure, to the power 1. So therefore, X by M is equal to K by P, Kp1, whereas K is your constant. At higher temperature, we know that it will become constant over here. Ps, equilibrium state, will be reached. So at higher pressure, X by M will be a constant. Therefore, X by M is directly proportional to P to the power 0. Then it will become a constant. So K by M is equal to K P naught over here. But during the intermediate, from the lower to the higher to the equilibrium state, the rate of adsorption is increasing over here. So X by M is directly proportional to P1 by N, or it will be X by M is equal to Kp1 by M, and taking log on both the sides of this temperature at this temperature, so it will be log K Xm is equal to log K plus 1 by N log P. Well, 1 by M will be your slope. This is your slope, which is indicated by 1 by N. This is your intercepts, which will be denoted by log K. And this is your log Xm and log K. So if we plot a graph between log Xm and log P, a straight line will be obtained. And the slope of this line will be equal to 1 by N. And the intercept on log X by M axis will correspond to your log K. This is all about your adsorption isotherms. Now we will move to adsorption isobars. Iso means same and bar mean pressure. Now here the pressure has been kept constant, whereas the temperature is changed. So isobar depict the effect of temperature on the extent of adsorption. This is your physisorption and this is your chemisorption. Physisorption, as I have told before also, that is your physical adsorption, where the weak van der Waals forces exist between the adsorbate and adsorbent, whereas in chemisorption it is your chemical adsorption, where the strong chemical bonds exist between your adsorbate and adsorbent. You can see here at constant pressure, the rate of in physisorption, the rate of adsorption goes on decreasing with increase in temperature. As we know that in physisorption, adsorption process is a reversible process. So as the temperature increases, desorption process take place. Therefore, the rate of adsorption goes on decreasing here. In chemisorption, first the rate of adsorption increases, which means that the temperature provide the initial activation energy so that proper bond could be formed with the particles of the adsorbent. When all the species of the adsorbate has been properly oriented, a further rise in temperature will decrease the extent of adsorption, as in case of physisorption. So in physisorption, there is a direct decrease in the rate of adsorption with increase in temperature, whereas in chemisorption, first the rate of adsorption increases due to the increase in the activation energy due to the formation of the bonds between the adsorbate and adsorbent. Once all the bond has been formed here, the rate of adsorption decreases with increase in temperature. So here some applications of adsorption are there. They are used in the removal of coloring materials, in gas mask, in dyeing of cloths, and in ion exchange resin, in chromatography. So this is all about your adsorption process.